part of the discussion on safety engineering, and hopefully in a second or two, there we go. The other people that participated are listed right over here. I thought what was really interesting, and you'll see this was reflected in our conversation, was that there was a lot of diversity in geography, um, and that sort of brought to light a lot of different perspectives I think would be useful as this topic is discussed throughout GP Write. So I just take a few minutes to sort of set the stage of sort of how I sort of view the role of safety in the context of GP Write and maybe more broadly in synthetic biology by sort of like drawing a parallel to a lot of efforts that we're probably a lot more familiar with, which have really involved safeguarding information that many of us care about in the internet, whereby over the past several decades, this incredible technology has emerged that allows us to basically access and disseminate information throughout throughout the world in a matter of seconds. And what's also important here is that there are a lot of efforts that have been necessitated by various threats that have basically safeguarded this information on the internet. And so I sort of view the role that this element plays in GP Write and maybe more broadly in synthetic biology or biotechnology is an important effort to safeguard the systems that we're working with to really fully realize the potential of biotechnology. I also think that this topic has really important relevance and links to a number of other workshop groups. In particular, I would sort of draw some important ties as sort of the safety feature sort of naturally links some of the technical efforts that many of us are pursuing to some of the LC components that we heard before. And I'll sort of reference some important quotes from the Presidential Bioethics Commission report that came out a number of years ago in synthetic biology and really highlight its relevance to GP Write and some of the endeavors that we're setting out to pursue, where clearly there's tremendous opportunity, but we also really have to pay attention to any potential risks that might emerge with the ultimate goal of really enhancing humanity and the environment. So now let's think from a more practical sense. When do we have to care about safety? So I think by and large, people have been benefiting from advances in biotechnology for about 40 years now. So most of these efforts and all these efforts are safe. And these are all typically conducted in more closed systems where we have really benefited from productions of lots of high-value molecules from medicines and chemicals, materials and fuels that have been produced in bio-based systems. But now, as our ability and our sophistication to engineer more complex genetically modified organisms is emerging, there are a lot of potential to start to apply engineered organisms in more open systems or open release applications. And I think it's in this context that we really have to take some of the dialogue and some of the early steps that have been developing in this particular area over the past 30 or 40 years and really advance them. And so some specific examples might be engineered probiotics, which could be deployed in clinical settings, or engineered microorganisms that could solve a number of important environmental applications that could span from bioremediation to carbon sequestration, for example. And so these efforts really are going to require robust biosafety and biosecurity measures. The two technical features I would sort of bring to light right now really rely on engineering intrinsic biocontainment, which effectively links the viability of engineered organisms to defined synthetic environments, so that basically they cannot just grow in the wild in nature. And the other element is genetic isolation. We've heard these a number of times throughout the meeting, but effectively being able to prevent the exchange of genetic material between organisms or between organisms and viruses. And these concepts are not entirely new. In fact, some of them were first introduced over 40 years ago when recombinant DNA technologies were first presented, but now these are really becoming important engineering objectives that we actually have to address. And sort of going beyond that, there's a lot of important reasons to think about engineering these types of safeguards into the systems that we're working in. I've covered a number of them. And there's also some important aspects from an industrial perspective that could really enhance the distribution as well as potentially foster more partnerships across industry if certain types of organisms and their proprietary efforts have been basically secured. And I would say over the past few years, particularly there's been particular advances in engineering biocontainment, where up until 2015, the state of the art was basically an escape frequency of about 1 in a billion. And over the past few years, we've actually increased that several logs. So I think there's a lot of important things that are advancing in this space. Now, sort of bring us down to what we discussed during lunch. I'm trying to sort of break this down to a number of the key points. One of the interesting one was first messaging around the term safety. So is that actually the right terminology that you want to go after? Because it gives this connotation of an all versus nothing. And perhaps a lot of what we're doing really is safe, but what we want to really do is enhance those safety features or endow more safeguards. And the other element here is really to think about more considering the relative levels of risk, and if that might be the more important element here to focus on. And related to safety is how do we actually define safety? This is also where the various people from China, Japan, and the US sort of had different perspectives. It could be defined differently in different countries. And clearly, the use and the application of those really will guide the types of safety measures as well as the associated risks. So there's a lot of clarification that needs to be introduced surrounding this. And if you sort of think about and drill down more on the topic of risk, we really should come up with metrics to determine what levels of risk are needed for a given use. So can we, given some of the state-of-the-art safeguarding technologies that we've developed to date, can we immediately employ them for various applications, both in closed and open systems? How do we quantify the risk? And what's the burden of proof? And then also, how do we then expand that to the regulatory level to basically empower the agencies that are going to regulate these products to actually enable them to actually enter the market? And then obviously there's some technical elements. So I want to close by just sort of highlighting some of the features that we've sort of put together in some of the Ultrasafe cell lines. I'll just leave it up here because you guys saw this in the paper that was published last year as well as in George's talk from yesterday, and just sort of open the floor back to my colleagues who participated in the discussion to see if there are any salient points that we discussed that I might have missed in this discussion. So I'll sort of pause here, see if there's any points that others think we need to raise, or if there are questions from the audience that you'd like to discuss at this point as well.
I remember last year the prevent formation of germ cells one was quite a strong thing that was discussed at the meeting last year. Did you think about ways that can be engineered? Would that be easy for someone to hack around?
I'd probably shift that question over to Jeff to see if you've thought more deeply about that one.
Not really.
So Tom, stay tuned. And I guess that sort of speaks to sort of some of the sort of observations I made, is that this is very much an ongoing discourse, and I think we will really have to sort of assess different sort of safety measures along the way. But I think something that is going to be critical in this effort is the importance that we put on this topic, as well as depending on projects that might come through, identifying if and when safeguards really need to be implemented in those efforts. Yep.
Just a thought along the sort of previous question. It seems that there are two different questions. One is, how do you build something, design something that is safe in terms of not going wrong? And that's an achievable goal. The question, how do you prevent something from being hacked, is probably not an achievable goal, or it's very difficult to think about, or even draw edges around that problem. So, you can easily think of ways of preventing germline. Can you prevent people from putting genes back in? That's a very different question, right?
It's a good question. I think it's challenging, but I think there are ways to do that. I think, and we've considered ways to sort of discreetly introduce various safeguards, as well as unique ways to decode them into the actual genomes, whereby it could actually be quite challenging to hack. It's non-trivial, but I think it's actually achievable. I'm out of time. Thank you.